Welcome back, and we're going to get some more practice with law of cosine examples. And so we saw in the last two videos that we had a side angle side context, right? And so now we're going to work with a different context where it is side side side. Okay, so we're just going to take a look at this triangle. So we have triangle ABC and C, and angle or side length A is really long. Okay, so we might be in some sort of scenario like this. Um, okay, maybe I exaggerated a little bit. I probably did. So let's make our triangle maybe just a little less obtuse. Okay, something like that. So this is going to be side length A, which is 62, and then B and C. C is 41 and B is 48. Okay, and so now I need to find the other components of the triangle, so the other angles, right? So I need angle A, I need angle B, and I need angle C. Okay, so let's pick A first, just for fun, because it's the first letter. Okay, so I'm going to do for angle A, right? I have to use the version that is A squared, so 62 squared is equal to B squared, 48 squared, plus C squared, 41 squared, minus 2 times 48 times 41 times cosine of A. Okay, and so now I need to go ahead and solve for cosine of A. So let's see, this would be 62 squared minus 48 squared minus 41 squared, all divided by negative 2 times 48 times 41. And we are going to remember that this in the denominator all needs to be in parentheses when we're putting it into our calculator. Yes, yes. Um, and so then this ends up being about 0.0358 for cosine of A. And so if you do inverse cosine of each side, you get that A is approximately 87.9 degrees. Okay, so that's helpful, 87.9 degrees. So my drawing obviously isn't to scale because that's darn near a right angle. Okay, so moving on, it is what it is. Okay, I'm going to move on and find angle B next. So for angle B, again, I need to set it up with law of cosines. So I would do 48 squared is equal to 62 squared plus 41 squared minus 2 times 61 times 41, 62 times 41 times cosine of B. Okay, so then solving 48 squared minus 62 squared minus 41 squared all over negative 2 times 62 times 41 in parentheses in the denominator is equal to cosine of B. And then going forward and just isolating B out of all this. So, okay, do the calculation, do inverse cosine. Okay, I get that B is approximately 50.7 degrees. Okay, so that is what I got for B. And then for angle C, okay, this would be just 180 minus 87.9. These are all degrees, minus 50.7 degrees. And I get that C is equal to 41.4 degrees. Okay, and technically, since the others were approximate, this would be an approximation as well. Okay, so I found all the angles. Okay, so there we go. Oh goodness, word problems. We were probably hoping we would avoid word problems, but this one is intense. But I think with a lot of these, we just need to go slow and go through the language line by line. Okay, so triathlete coordinator has given participants an option of entering a straight river at one of two places. So they enter over here. Okay, I'm just going to make that note, enter over here. And then they must swim from one of the two places to the indicated position. So this is their goal. They want to get over here. Okay. Diagram is shown below. The coordinator determines that the distances from A to B. Okay, here we go. A to B is A to C and B to C. Okay, so they're 20 or 213 feet from A to B, from A to C, okay, that is 3635, okay, and from B to C, that is 3470, okay, and then we want to know what angle the triathlete must swim at to reach angle C if they leave from A. So this is, let's see, I'm okay if we talk about this as angle A. Technically, if you enter here, you have to turn. So this is the angle A that we're really looking at, okay? And then from B, again, if you're entering from here, you have to turn over here. So this is your angle B, okay? So we want to look at those two angles, okay? B seems easier because that's within the triangle. I'm gonna call the other angle within the triangle corresponding to angle A complement, okay? Actually it'd be A supplement, but maybe I'll just do it as A prime. There we go. Okay, so let's find angle B first, okay? How do I do that? Oh, wait, my triangle is in blue there. It's the same thing that we just did, side, side, side criterion. So if I want to find angle B, right, I'd have to do the side opposite. 3635 squared is equal to, okay, the other side squared, 213 squared plus 3470 squared minus 2 times 213 times 3470 times cosine of B. Okay, that's fine. And then I can say 3635 squared minus 213 squared minus 3470 squared all over negative 2 times 213 times 3470, okay, is equal to cosine of B. And then, okay, get rid of cosine, put cosine inverse on there, and we should have our answer, okay? So after we type that all in a calculator, I get 139.7 degrees if I round to the first decimal place, okay? Okay, that's fine. And so let's just see what we get for A prime, and then we have to, subtract that from 180 because we're actually looking at the supplement. Okay, so I'll do this in red. Okay, so for A prime, okay, I would say, okay, side, side, side criterion, right? So 3470 side opposite is equal to the other two sides, 213 squared uh, sorry, 3635 squared minus 2 times 213 times 3635 cosine of A prime. Okay, that's in our triangle. And then again, I would move everything over. So 3470 squared minus the 213 squared minus 3635 squared. Okay, and then divide all that by the negative 2 times 213 times 3635. Okay, make sure that that's all in parentheses. And actually, you should make sure the numerator is in parentheses too. And then this would be cosine of A prime. Move the cosine over by cosine inverse. Okay, you can work out the steps on your own if you wish. Okay, and when I do this, I that A prime is approximately, I should change this to approximately, 38.1529 degrees, okay, which means that A is 180 minus A prime, okay, and then if I do 180 minus this, I get that A is approximately, if I round to one decimal place, 141.8 degrees, okay. So, and it makes sense that if you are going further from this, further from B, that if B was already a pretty large angle, that you have to turn even more, right, to get to C if you go a bit further from where you wanted to go into the water at B. Okay, so we have solved the exercise. I should write a sentence, so I should say the angle to swim at or swim to C from A is 141.8 degrees, and from B is 139.7 degrees. Okay, um, just because it is a context problem and we need to report our answers in sentence form for context problems. Okay, so law of cosines, we've seen side criteria twice in this video. First video we saw angle side criterion, and that's really the only two instances where you can use law of cosines. There is another law which covers the other cases of triangles, which we will see in the next section.